Okay, kia ora. I'm just making a really quick video on how to balance half equations. I was going to use the recording from the meet, but I discovered at the end that I couldn't hear any of you speaking, and there's just like a whole bunch of people answering my questions and me going, anyone want to answer? And you totally are answering. So I'm just gonna put that in the hole and remember that for some reason Google Meet just mutes the tab immediately as soon as I open it, which is really excellent and great. So anyway, we're going to get stuck in. So we've got 4 rules for balancing half equations. Rule number 1, if it's going to work, which is not, there we go. 1 is to balance all your major atoms first. So we want to make sure that all of our atoms that are not oxygen and not hydrogen are balanced on both sides from the beginning, because otherwise it messes up our charge at the end. Our second rule is to balance all oxygens with water. So every oxygen needs to have a water counterpart on the other side to make it balance. Step 3 is to balance all H's with H pluses on the opposite side. And our last step is to balance charge with electrons. So I'll walk through how that works with this example here with dichromate. So our first step is to balance our major atoms. Our major atoms, in this case, are chromium, because oxygen is our step 2. We're going to ignore that until we get to step 2. So I can see that I have got 2 chromiums on the left-hand side, and I only have 1 chromium on the right-hand side. Now, the only way that I can change this at this point is to add a big 2 in front of that chromium. It doesn't make sense to have a little 2 here because those 2 chromium ions have not bonded together. Instead, I have 2 distinct chromium ions that are present in this mixture. So I have my dichromate on the left-hand side and 2 chromium ions on the right-hand side, and I have done step number 1. Now, step number 2 is to balance my oxygens with water. So I can see that on the right hand side at the moment I currently have no oxygens at all. On the left hand side, however, I have got 7 oxygens. Remember that the number to the right of the element tells us how many of that element are present in the molecule. So I have 7 oxygens on the left hand side and none on the right hand side. So in order to balance that, I need to add 7 waters to the right hand side. So now I have 7 oxygens on the left and 7 oxygens on the right. We then come to our, oh my gosh, brain, there we go, to our third step, which is to balance our, there we go, put it there, our hydrogens with H+. So currently on the left hand side I have got no hydrogens at all, but on the right hand side I've got 7 waters. Each water has got 2 hydrogens in it, which means that in total I have got 14 hydrogens. So we've got 7 waters, each water has 2 hydrogens, therefore in total there are 14 hydrogens on the right hand side. So in order to balance them, I need to add H plus to the opposite side so that each side has the same number of hydrogens. So I'm going to add 14 H plus to the left hand side there. And my last step, just to recap, we've got 2 chromiums on each side, we've got 7 oxygens on both sides, and we have 14 hydrogens on both sides now. So my last step is to balance the charge, and so in order to work out the charge on each side, we need to look at the charges on our ions. So if a molecule, for example water, does not have a charge on it, so there's no little charge in the top right corner of it, then we can disregard it. It doesn't, it's not involved in the overall charge at all because it doesn't have one. So we're just going to look at the charges we can see. So we'll start with the easier side first. I've got 2 Cr3+, so each Cr3+ contributes +3 to our charge, and we have got 2 of them, which means that in total we have a charge of +6 on the right hand side because our water doesn't give us anything. On the left hand side I have got Cr2072 minus. I've only got one of them, and so even though it's really chunky, it's a really big molecule, it actually only contributes 2 minus because I've only got one ion, and that one ion has a charge of 2 minus. So we have a charge of -2, and then my H pluses, so each hydrogen has a charge of +1, and I have got 14 of them. So in total, I have 14 times 1 gives me +14. So 14 plus -2 equals +12. So I'm getting 14 plus 1s from my H+, I'm getting 2 minus from my dichromate, and then 14 plus -2 gives +12. So that means that on the left-hand side, I have an overall charge of +12, and on the right-hand side, I have an overall charge of +6. I want these to be the same number because I want everything to balance. So because I am adding electrons, each electron is worth -1. So I can only ever bring the charge of a side down. I can never bring it up. So I can't make this +6 turn into a +12 because I'm adding negative things. I can only go down. So what I'm going to need is I'm going to need to go to my highest side, which is my +12, and I am going to add the relevant number of electrons to the side. So if I look at it, I see I've got 12 and 6. The difference between these two is 6. So if I added 6 electrons to this side, I'd be adding -6, which gives us +6. It's 12 minus 6 is 6, which is the same as that. So each electron is worth a -1. So if I add 6 electrons here to that side, now we are +6 on both sides, and we are balanced. We have done all 4 of our steps. We have balanced our major atoms, 2 chromiums to 2 chromiums. We have balanced our oxygens, our 7 oxygens, by adding 7 waters. We have balanced our 14 hydrogens by adding 14 H+, and we have balanced our charges of +6 and +12 by adding 6 electrons to the more positive side, so that both sides have a charge of +6. Hopefully, for those of you that have done chemistry before, that is familiar. For those of you that haven't, hopefully that was a useful overview. Please let me know if you have any questions. Just send me an email, and I promise that next Google Meet, if we have one, I should be able to hear you properly. I don't really understand what I did, but whatever. Anyway, cool. Thanks. Have a great day.